Today we're moving on to the last section of Unit 5, which is starting to talk about expressions and some equations. And we're going to look at some expressions today. We're going to be adding, subtracting, multiplying, and dividing rational numbers. And that's why it's been so important to this point to practice those skills with the rational numbers, with adding, subtracting, multiplying, dividing. They all have those different rules that we really need to be familiar with. And now we're going to apply it to expressions. For the first question, before we talk about it, I want you to look through the 4 scenarios there and decide if each statement is true or false. Hopefully they will not require a calculator. I do want you to try to do this mentally. So take a look at those 4 bullet points, just write a T or F next to them, and then we will quickly discuss. Now for the first one, it says, we've got these 2 negative numbers here. Because they're side by side with no operation between them, it means that we're multiplying them. And if we multiply 2 negative numbers, hopefully you realize that those have the same sign. So we would have a positive answer, not a negative answer. This would be a false statement. For the next one, it's really important that you pay close attention to the place values, because it seems like the answer to 10,000 minus 99,999 would be 1, but it's really not. If you look closely, we're taking away almost 100,000 from 10,000. So that is going to give us a very negative number, and a very negative number is going to be less than 0. That would be a true statement. Next, we're doing some more multiplying here because we don't have an operation between these two. If we multiply 34 by negative 43, is that going to equal 0? No, it is definitely not. So that would be a false statement. And of course, to talk about that one real quick, the only way to get 0 as a product of a multiplication problem is if one of our factors is 0. So that would be a very clear giveaway that this is not going to be a true statement. Finally, let's look for some similarities here. So we've got 30 times negative 80. We've got 30 times negative 80 on this side. On the left, we're subtracting 50 from it. And on the right, we're subtracting this product from 50. Now, what we know about subtraction is you can't interchange the two numbers being subtracted, or you get a very different answer. You get the opposite value. So this too would be a false statement. Those are not going to be equal on the left and right side. Now, let's look at this table. So I'm going to fill in the first row for you. Then we're going to take some time for you to do the same. And then we're going to kind of analyze what we get as a result here. So the very important part, and I can see that probably on a lot of your copies it might be hidden. So please write this down just above it if you can't read what it says. But what we're doing is we're taking different quantities of A and B and we're writing them into different expressions. So in this case, our A and B values are negative 1/2 and 6. Now, negative can also mean opposite. If you think about a number line, 0 being in the middle, if 4 is on one side, then negative 4 would be the opposite value. It's the same distance from 0, it's just opposite it. So if we look at it this way, if our A is negative 1/2, then the opposite of that is positive 1/2. Okay? If we look here, we've got the expression negative 4b, negative 4 times b. So we're taking negative 4 times our b value, in this case it's 6. So what I'm doing, I'm just going to write these. You don't have to do that, but I want you to be able to see what I'm doing. So negative 4 times 6 will give me negative 24 as an answer. This is all you would have to write into the box. For the next one, we are adding, but we are adding b to the opposite of what A is. And remember, we already have that listed here, so what we're going to be doing is 1/2 the opposite of A plus B, which is 6. So our answer is 6 1/2. Next, we do a division problem. A is negative 1/2 divided by negative B. Now, we don't have negative B anywhere yet, but that just means the opposite of what B is. If B is 6, negative B is negative 6. Now, here we have the same sign. We're dividing two negative numbers, and when we divide two negative numbers, we get a positive result. So our answer is going to be positive. It's 1/2 divided into 6 parts, 6 groups. So that is 1/12. That's positive 1/12. Now we talk about some exponents. We haven't done a lot of this, but a squared is a times itself, a times a. And b cubed is b times b times b. Please remember, it's not b times 3 or a times 2. It tells us with this exponent how many times to multiply the base number by itself. In a squared, if a is negative 1/2 and we multiply it by itself, multiplying two negatives becomes positive 1/4. And lastly, for b, b is 6, and we're multiplying that by itself 3 times for 216. That's the first row done for you. What I'd like you to do now is look at these next two values for a and b and go ahead and complete the row. Remember, we're using different values. Really, we still have the same quantities, but our positives and negatives have changed. Now a is a positive value and b is a negative value. So let's see how these will change. A lot of them could be similar. So pay close attention to your positives and negatives. All right, now that you've done that, let's go ahead and fill it in and check your work. Please make any corrections if you do not have what I'm entering here. And notice the values are just about the same as what we already did. The difference is a lot of them have changed their sign. Here we had positive, now it's negative. Negative became positive. We did have a couple that stayed the same here in the middle. And let's look at the last row. All right, so please make any corrections if you need to change any of those. While you're waiting for each other to change those in class, would you think about these next 3 questions? So looking across the row, we're trying to find the largest value, the smallest value, and the closest to 0. Okay, so take a look at that first row, the largest value. The largest value here I see is 216. So I'm going to use a symbol to kind of show the largest value in each of these. And I'm going to circle that in green. That's right here. If I look at the next row, the largest value here is 24. And then finally, the largest value in the last row is 36. For the smallest value, I'll use yellow. The smallest value. Now, any negative number will be smaller than a positive number. So if there's a negative number, that automatically is smaller than any of the positives. If I look across here, we've got only one negative value, so that's easy right there. For the next one, though, we have several negative values. Now, the smallest value is going to be the furthest away from 0, or the farthest to the left on the number line, and that would be negative 216. For the last row, negative 12 would be our smallest value. Now, the last thing it asks us to do is to find closest to 0. closest to zero value. That could be positive or negative, but the closest to zero. So I'm looking here, I've got a few fractions, which I know are all less than a whole number. They're all positive. And we've got to pick the smallest fraction to be closest to zero. That would be 1/12. If we look at the next one here, we've got two fractions, one positive and one negative. Whichever one is the smaller fraction is going to be closer to zero, and that's 1/4. So closest to zero is positive 1/4. And, oh, I'm sorry, I picked the wrong one here. It's actually positive 1/12. I missed that one. So that would definitely be closer to zero, being that it's a smaller fraction than 1/4. And then lastly, we've got, well, this is a mixed number, meaning that it's a whole number and part of another whole number. So that's too big. And there's only one fraction here, -1/8. That would be our closest to zero amount. Now, looking at those and kind of trying to recognize some patterns here, what do you notice? I mean, hopefully you notice that our largest values, which were all circled in green here, our largest values, and two of them were our exponent numbers. And I think a lot of that has to do with how exponents work. They get increasing in size very quickly because of the powerful process that an exponent goes through. We also had multiplication here that showed the largest value in this row, and that was only because we multiplied two negative numbers, which turned our product positive. All right, there's all kinds of patterns here. Let's continue on. I don't want to make this video too long. Let's look at this next example. So we need to select an operation to make the equation true. Now, what we have to see here is what's happening. So we are starting with 24. Our result to our equation is less than 24. We're decreasing the value of 24. So in order to do that, we would need to multiply. If we divided by 3/4, that would give us more than 24 as an answer, because there's more than 24 groups of 3/4 in there. That would not work. Multiplying is going to tell us we're going to take 3/4 of this amount, and that's 18. Let's look at the next. So we're taking 24, we're ending with -32. Okay. The difference also is that our other number is also negative. So we don't want, we're working with a positive and negative value. Those are different signs. So using multiplication or division, if we have different signs, we have a negative answer. That makes sense. So we should multiply or divide here. Now remember I said to increase this number, we would divide, because there's more than 24 groups of 3/4 in 24. Let's look at the next one. Going from 12 down to -3. We're losing a lot of value there. We definitely wouldn't add 15. We wouldn't multiply, because multiplying two positive numbers gives us a positive result, and same for division. So the only thing that would work here would be subtraction. Then we're going from 12 to 27, so we're increasing in value, but we're using a negative number. Using a negative number to increase this value is kind of tricky. So if we added -15, that would just make this smaller. It would become -3, so addition won't work. If we multiplied, we'd get a negative answer, or divided, because only one of these numbers is negative. So the only thing left is subtraction. And if we're subtracting a negative value, it's like adding the opposite of this negative value. It's like adding 15, and that would make 27 happen. Finally, we've got two negative numbers. We're trying to get a positive number here. So having the same signs, we're either going to multiply or divide to get a positive number. If we multiply, just like what happened up here, we get something smaller. So we have to divide to get a larger value there. Okay, now looking at the last, I do want you to try most of these, but one thing you do need to keep in mind is order of operations, and this is going to be hugely important as we continue through what we're doing. In order of operations, we always take the most powerful operation and do it first. So, besides parentheses, which focus our attention on something that needs to happen first, the most powerful operation that we just recently talked about was exponents. And we would do those exponents because they're going to change this equation, this expression, the most. After that, our most powerful operations, the thing that changes the values of numbers the quickest, is to multiply, or its inverse operation, divide. And then finally, our weakest operations are to add and subtract, because that's just combining or taking away. Oh, I should use the letters, add or subtract. Now, because multiplying and dividing are inverse operations, because they're equal in strength, we just solve them in the same way that we would read a sentence. So we're always going to go left to right, and it's the same for addition and subtraction, left to right. So let's do one together here. For 15, we've got some parentheses that are focusing our attention right here on this expression, 6 minus 4. That's what we have to do first. So I'm going to solve that. 6 minus 4 is 2. I no longer need the parentheses because I just solved what's in it. And I think the best strategy is to rewrite the rest of the expression. So take what's left and move it down. Now, I've taken care of parentheses. I don't see any exponents here. So I'm looking for multiplication or division, and I have both. Now I'm going to solve it left to right. It doesn't mean I'm always going to do multiplication first. If this was reversed, I would do the division because it's happening on the left as I move to the right. But we're going to start with multiplying. 2 times 49. So that would give us 98 divided by 7. Now, I've rewritten it again so I didn't forget that last step. And then I'm going to solve. 98 divided by 7 is 14, my solution to the expression. If I didn't do the order that I just showed you, I would have gotten a different answer. You have to be very careful about that. So please write this down. Start top and work down to the bottom. Start with those most powerful operations and work down to the least powerful, and then come up with your answer at the end. But don't forget to rewrite the rest of the expression so that you don't leave something out as you're working through. Okay? Check the notes for the answers to the rest of these. If you have any questions, I'm happy to help, and I hope you have a great day.